Hello folks, how's it going? Mike coming back at you with another video on Foundations of Math 2. In the previous video, we talked about whole numbers and integers, the basic properties of and operations of addition, multiplication, subtraction, and division, how they work with those guys. We talked about the absolute value, and then we talked about the order of operations, PEMDAS. Please excuse my dear Aunt Sally, or whatever you know it by. In this video, we are going to talk about rational numbers. What the heck is a rational number, you ask? A rational number is any number of the form p over q, where p and q are integers and q is not equal to 0. We cannot divide by 0. That breaks the internet. The world implodes. Seems like we're heading there anyway with our pandemic, but we're not quite there yet, so let's not speed there. That number p that's on the top we call the numerator of the rational number, aka the fraction, and that q on the bottom we call the denominator. When the absolute value of the numerator is less than the absolute value of the denominator, we say that the fraction is a proper fraction. When the absolute value of the numerator is greater than the absolute value of the denominator, we say that the fraction is an improper fraction. So improper fractions are things where if you took the absolute value of it and you changed it into decimal format, you would get something greater than 1. Related, a mixed number consists of an integer next to a proper fraction, which is positive. How do we convert from a mixed number to an improper fraction? This is something very important to know how to do. So if you're given a mixed number, something that looks like this thing here, the way you write that as an improper fraction is you take c and you multiply it by that capital A, and then you add a b onto it. And that's your entire numerator, and that's all over c. The way that I like to visualize this is you go c times a c times a, and then you go plus there. Plus b. So here's an example of how this works. 4 and 5/7, that's how we read those mixed numbers. We say the integer 4, then the word and then the rational number or the fraction 5/7. So 4 and 5/7. We're going to take that 7, multiply it by the 4, and then add the 5. Using our order of operations, we do the 7 times 4 first, which is 28, and then we add 5 to give ourselves 33. What if you have a negative integer out front? That's okay. Ignore the minus sign for now. Don't completely forget it because we need to throw it back in at the end, but just work with the number part of the integer as well as the rational number or the fraction. So I'm going to do 3 times 3, which is 9, plus 2. That gets me 11 on top. The 3 stays on the bottom, and then we multiply that minus sign back in. Not all rational numbers are unique. For example, 1/2 and 3/6 are the same number. So if we're talking about two rational numbers, we may have to be sure that they're not the same number. But how would we tell if they were? We always want to take a rational number and put it into lowest terms. A rational number p over q is in lowest terms when p and q have no common factors, that is to say, besides 1. So how do we take a rational number that's not in lowest terms and put it into lowest terms? You're simply going to write the prime factorization of the numerator and the prime factorization of the denominator. Once you have that, you're going to see what factors you have on the top and bottom. Those factors that happen on both the top and bottom, you're going to cancel those factors out. And then whatever is left after you're done canceling out, that is going to be your rational number in lowest terms once you re-multiply those factors in the numerator and the denominator if you need to. You may find that you have more than one of the same factor in both the numerator and the denominator. That's fine too. You can cancel out more than one of the same kind of factor. Just as long as you're canceling out the same number from the top and bottom, as well as the same quantity of each number from the top and bottom. So I'll show you what I'm talking about with our next example. Let's take 24 over 30 and let's see what rational number this is in lowest terms. 24 is 2 times 2 times 2 times 3, and 30 is 2 times 3 times 5. So let's see what things we can cancel out here. I have a 2 on the top and I have a 2 on the bottom. I can cancel those guys out. I see that I have a 3 on the top and a 3 on the bottom, so I can cancel those guys out. And then here, there's nothing else in common with what's left between the bottom and the top. I have 2 times 2. I have a 2 times 2 on the top. I have a 5 on the bottom. So that's it. This gives us 4/5, and that is our given rational number, 24 over 30, in lowest terms. Next up, negative 30 over 48. Just like with taking a mixed number and converting it into an improper fraction, if you have to reduce a negative rational number into lowest terms, temporarily ignore the minus sign out front. Don't completely forget it, but just work with the number part of it, and then at the end, throw the minus sign back in. So 30 is 2 times 3 times 5. 48 is 2 times 2 times 2 times 2 times 3. Again, we see we have a 2 on the top and a 2 on the bottom. Those cancel out. A 3 on the top and a 3 on the bottom cancel out. And that just leaves us with 5 on the top, and then on the bottom 2 times 2 times 2, or 8. So negative 30 over 48 is equal to negative 5/8. How do our basic operations, addition, subtraction, multiplication, and division, that is, work with rational numbers? Multiplication and division are the nicest ones out there. When you multiply two rational numbers, you're just multiplying the tops, or the numerators, and you're multiplying the bottoms, aka the denominators. So a over b times c over d is equal to ac divided by bd. When you divide two rational numbers, with just one little flip, you can change it into multiplication. Saying a over b divided by c over d is saying the same thing as a over b times d over c. So if you have to divide two rational numbers, take the second rational number that's listed, flip it, and then change the division sign to a multiplication sign. So I have a over b times d over c, and that is equal to AD divided by BC. So as a couple samples here, we're going to find 4/7 times 12/17, and we're going to find 4/7 divided by 12/17. So let's see what we get when we do the multiplication. 4 over 7 times 12 over 17. Like we said, with multiplication, we're just multiplying the tops and we're multiplying the bottoms. So we get 4 times 12 on top, which is 48. And on the bottom, we get 7 times 17, which is 119. We cannot take this number and put it into any lower terms, but if you could, you would want to do so. Now for the division, 4/7 divided by 12/17. I'm going to take this fraction here, and I'm going to flip the terms. The 17 will go up top, the 12 goes on the bottom, and that division sign changes to a multiplication sign. Just like we did with multiplication, multiply the tops and multiply the bottoms. You get 68 over 84, which you can reduce more. And when you do reduce that, you get 17 divided by 21. Now, addition and subtraction, a little bit more complicated, a little bit more involved. These can only occur when the denominators of both fractions involved are the same. And if they're not the same, then that's where the little bit more work can come in. So whether you're adding or you're subtracting, here's how you find the difference or sum of A over B and C over D. This is assuming that the bottoms are not the same. First thing you want to do is you want to find a common denominator between B and D. A common denominator or a common multiple is simply B times D. So then what you're going to do, you're going to take each of your fractions and you're going to multiply it by a number divided by the same thing. You're going to take A over B and you're going to multiply it by D over D. Similarly, you're going to take C over D and you're going to multiply it by B over B. Now, what you're actually doing here is you're actually just multiplying the fraction by a 1. And when you multiply it by 1, you're not changing the quantity that you have, you're just changing how it looks. It's okay to change how it looks as long as you don't change the actual quantity that you have. But what we're doing when we make these, or when we do these multiplications, is we're creating a common denominator between these two fractions so we can easily figure out what the difference or sum will be. So this guy turns into AD over BD. This guy right here turns into BC over BD. Now, you just add or subtract the numerators only. And which one you do, obviously, is based on the given problem. So you have AD plus or minus BC all over B times D. So we're going to see some samples here. 3/5 minus 6/11. Clearly, the bottoms of these fractions are not the same, so we need to find a common multiple or a common denominator between these two things. Like we said from our process here, a common denominator between B and D is simply the product of those two things. So 5 times 11 is 55. I'm going to multiply on the top and bottom of this fraction by 11. I'm going to multiply on the top and bottom of that fraction there by 5. So that's what we're doing here in this next step. 11 over 11 times 3 over 5 minus 6 over 11 times 5 over 5. As we know, multiplying irrational numbers, just multiply the tops and multiply the bottoms. 33 over 55 minus 30 over 55. And then we just subtract the numerators in this case to get 3 over 55. Try this guy on your own. Try to figure out what 11 over 9 plus 2 over 7 is going to be. Go through that same process, find the common bottom between these two fractions, multiply on the top and bottom of each fraction by the appropriate number, and then combine the numerators. So pause it here. Once you think you have the answer, press play, and we'll see if you are correct. All right, so let's see what you got. You had to take the 11 over 9 and multiply it on the top and bottom by 7. And then you take the 2 over 7 and multiply it on the top and bottom by 9. You then have 77 over 63 plus 18 over 63. 77 plus 18 is 95. So we have 95 over 63. And this could not be reduced any farther. So that is the end of our work for that particular problem. Rational numbers can be identified by their decimal representation. Just by looking at a decimal, how can you tell if you have a rational number? If a decimal is finite or is infinite with a repeating pattern, then the decimal is that of a rational number. Some examples here. 4 over 9 is 0.4444, and that keeps on repeating. We use this bar over the 4 there. That bar means that we keep writing that number over and over and over afterwards. And then 56 over 99 is 0.5656565656, so on and so forth, or 0.56, and the 56 is underneath that horizontal bar. Some rational numbers are tricky. If you look at the decimal on a calculator, their decimal representation may not seem to have a clear repeating pattern. This can be due simply to the number of places that the calculator shows, and it could be that the pattern is a number of digits that's longer than the number of places that the calculator will show. So it can be tricky. There are some sneaky decimals that may not seem like they're decimals for rational numbers, but they actually are. So just something to be careful of there. But we all have access to calculators, and we all have access to calculators that can help us convert between decimal form and fractional form. So this concludes our video on rational numbers and the basic operations with them. In the next video, we are going to talk about irrational numbers. If you have any questions or comments, please reach out to me, guys. Magic wands, crying SOSs, fires on beaches, signs, things in the air. Otherwise, until the next video, take it easy, folks.